Hello, grades of. Welcome to this session. It's an algebra session, and today I just want us to look at this first topic in your maths paper 1. I'll just be basically showing you how you can solve nature of the roots related problems. We're just gonna be treating some Department of Basic Education past papers, and let's go. Okay. All right, let's just do some quick recap on nature of the roots. So before getting deep into nature of the roots, you must understand what is roots, right? What are the roots? So now by the roots we mean the x-intercepts. Okay, so the roots now are the x-intercept, and remember how you solve for the x-intercept. You let y to be equals to 0, and then you solve for what? You solve for x. So those x values that you solve for are known as the what? As the roots. Now, so when we say nature of the roots now, nature of the roots, so it means it's a way in which your roots can be, right? So that is what we mean when we say the nature of the roots. So now we want, and we really more focused on when we say roots, we're talking about the ones for what? For a quadratic graph, so we want to know their nature, right? And you know that a quadratic graph is denoted by standard formula x squared plus bx plus c. So to solve for the x-intercept there, I let my y to be equals to 0. So in other words, you let your x squared plus bx plus c to be equals to 0 and solve for x. And someone can basically use a quadratic formula to say x equals to minus b plus or minus root of what? B squared minus 4ac divided by 2a. Okay, so when you solve for this x, obviously you're gonna get two answers. You get the first x and you also get the second x. So with those two x values that you got, we can now determine their nature to say what is the nature of these roots. Can you see? So that is basically what we mean by nature of the roots. Okay, so how do we determine nature of the roots? Oh, basically, let me just tell you how many natures of the roots we have, right? So natures of roots. So we only have 3 natures of roots. Number 1, your roots can be real. Number 2, the roots can be what? Your roots can be non-real, or what we also known as undefined. Okay, undefined, or sometimes they can be called what? Imaginary. So imaginary. Lastly, your roots can be what? The roots can be equal. So that's just some quick recap on nature of the roots. The roots can be real, non-real, or also equal. So how do we know after calculating our roots, or maybe how can we determine this nature of the roots to say these ones are real, this one are non-real, and this one are equal? So when the roots are real, non-real, or equal, or in order to determine nature of the roots, we have to calculate something called delta, and it's denoted by that triangle there. So delta, after calculating delta, you'll be able to tell whether your roots are real, non-real, or equal. So how? So delta is equals to b squared minus 4ac. Okay, so delta is equals to b squared minus 4ac, and you can see that in your quadratic formula, delta is actually something that is equal to something inside the root there. Can you see? So that is our delta. So how will we know after calculating delta that our roots are real? So if your delta is greater than 0, sometimes they can say greater or equals to 0, then your roots are real. Okay, so if you calculate delta and you get that your delta is positive, in other words, it's greater or equals to 0, then your roots are real. How do we know when our roots are non-real, undefined, or imaginary? It's when your delta is negative. In other words, your delta must be less than 0. In other words, it must be negative. Okay, so then we'll conclude that our roots were what? when non-real. What if our roots are equal? It is when you calculate delta and it is equal to what? It is equal to 0. So when your delta is equal to 0, you can conclude that your roots are what? Are equal. So if you're given a nature of the roots problem and you just basically see this as we start treating these past papers on nature of the roots related questions, that if you're given nature of the roots, you'll definitely always have to calculate your delta so that you can be able to tell if your roots are what? Are real, non-real, or are equal. Okay. Okay, let's quickly look at nature of the roots understanding. And I just want you to understand this rather than memorizing if delta is greater than 0, real, less than 0, non-real, or equals to 0, equal. Okay, so look at the graphs that I've sketched below. Let's take a look at the first graph, number 1. If they say calculate the x-intercept, what will you say? X equals to minus 3 or x is equals to what? X is equals to 2, right? So, but then if you take a look at minus 3 and 2, these are real numbers. So you'll definitely conclude that the roots here are what? The roots are real. And also when you calculate delta, you'll definitely get it as being greater or equals to 0. Can you see now with understanding that really when you say the roots are real, you mean that they are real numbers. So that is their nature. Okay. Number 2. What can you say about the roots here? You don't have the x-intercept in graph 2, right? Because your graph is just cut on the y-axis here and there's no x-intercept. What can you say? X equals to what? No solution or not applicable, right? So in other words, here the roots are what? The roots are non-real. They are non-real. They don't exist. We don't have the x-intercept. Or in other words, they are what? They are undefined. Or someone can say they are what? They're imaginary. Okay, so someone can say they're imaginary. When you calculate delta, you must get it as being less than 0. Delta is less than 0 there. Okay, the last graph. You have your x-intercept here at 1. So x equals to 1 or x equals to 1. So here you have two x-intercept. They are both equals to 1. So basically, if you have a turning point on your x-axis, just know that you have two x-intercepts. Those kind of graph when you are solving, maybe when you are factorizing, you want to determine the x-intercept, it was like that. X minus 1 into x minus 1 equals to 0. Then when you solve x equals to 1 or x equals to 1. What can you say about their roots? Their roots are equal. So here, the roots are what? Are equal. Can you see now with understanding? In other words, delta will be equals to what? Will be equals to 0. Okay, let's quickly go and solve some past questions for Department of Basic Education on solving nature of the roots problems. Okay, let's now focus on some past papers on solving nature of the roots. Okay, so you are given on your number 1, the roots of a quadratic equation are given by the following: x equals to minus 4 plus or minus root of k into 3 minus k, all divided by 2. And the question says, A, determine the nature of the roots if k is equals to 2. Okay, if k is equals to 2, determine the nature of the roots. So this question is simply asking us to say whether our roots are real, non-real, or what? Or equal. And you know that in order to determine nature of the roots, we must first determine our delta. Okay, so we are going to calculate delta. We know that delta is equals to b squared minus 4ac, right? B squared minus 4ac. And we know that from a quadratic formula, we have our b squared minus 4ac inside the square root there. Can you see? And that will be k into 3 minus k. Inside the square root is our b squared minus 4ac. Now with this given delta, we can go and determine its nature of the roots, right? But we are given that k, if k is equals to 2, where there is k, I'm just going to put 2 and we solve for our delta. Can you see? So it will be 2 into 1 and the answer will be what? Will be 2. What can we conclude about the nature of the roots? Our delta is greater than what? than 0. In other words, our delta is positive. Someone can say greater equals to 0, but let me just say greater than 0. Therefore, we can conclude that the roots are what? The roots are real. Yes, they are real because delta is greater than 0. But for real, we say we can have two types. We can have rational and we can also have what? Irrational. Can you see? Irrational. And how do we determine? If it's rational, we know that delta is a perfect square. If it's irrational, we know that delta is not a what? Is not a perfect square. Can you see? So is 2 a perfect square? No. 2 is not a perfect square, right? So then it will be real and what? And irrational. Real and irrational. Real and irrational. So this is the nature of this root. Or someone can just end up to say real only because it had only 2 marks. So that's it. B, let's go to B now. Okay, for B, it says for which values of k will be the roots be non-real? Okay, for which values of k will the roots be what? Non-real. So we must first determine our delta here. We know that delta is equals to what? K into 3 minus k. Now they want the values of k for which this root is going to be what? Non-real. So we know that for non-real, our delta must be less than 0. In other words, we are going to calculate the values of k when our delta is less than 0. Can you see? So when there is delta, I'm going to replace with k into 3 minus k less than 0. Then we get all the values of k for which that graph will be less than 0. Okay, so if you go and do your number line, you'll find that your critical values are 0 and what? And 3. Can you see? 0 and 3. And if you can just, because this is a quadratic graph, k minus k, it's minus k squared. So we know that we have two shapes. We have a smile and we also have sad, right? It depends on which one you are using. You can use the method of drawing the arrows, but I really prefer this method of just sketching the graph there. So k is negative because if you remove k times minus k squared, so it's gonna be sad. So I'm just gonna draw sad there. Then we check where the graph is less than 0. So this line is where y is 0. So less than 0 is under the graph, right? Can you see? It's under the graph. So it's when k is less than 0 or k greater than 3. Because we are moving forward this side here, we are moving backward. That's why we're saying k less than 0. So when k is less than 0 or k is greater than 3, the roots are going to be what? Non-real. It means that if you substitute any value of k that is less than 0 there or that is greater than 0, you are going to get a negative square root there. And you know that a negative square root is undefined, right? It's error or imaginary. So that is what we mean that your x, now your roots are going to be what? Are going to be non-real or undefined, like that. Okay, so that's basically how you do it. Okay, let's move at this one now. For which value of k, and this is example 2, just taken from a past paper. For which value of k will the equation 2x squared minus x is equals to k have no real roots? Now they give you this question in a different format, right? It's not like the first one we were just doing this side, where you are just given a quadratic equation where they just solve for the roots. But in this one, they just give you a quadratic equation in its standard form, sort of like. Can you see? Because they just give you as in a form of linear bit. So to say for which values of k will the equation have no real roots. So what we have to first do before determining or using nature of the roots, you must make sure that your equation is in the form x squared plus bx plus c being equated to 0, right? So in other words, I'm just gonna take my k to the other side to be minus k equals to 0. Then it's perfect, right? So now I can go and determine the value of k for which the roots will have no real roots. So I must calculate delta, right? Because delta is the one that really tells us about the nature of the roots. So delta equals to b squared minus 4c. What is my a? A is the coefficient of x squared. Anything that is multiplied with x squared is 2. B is the coefficient of x. Anything that is multiplying with x is minus 1. And c is that one that is not multiplying with x, or the we call it a constant. It's minus k. So if I go and calculate delta, it's gonna be minus 1 squared minus 4. A is 2 and c is minus k. Can you see? So delta will be equals to minus 1 squared is 1, minus 4 times 2, it's minus 8, minus 8 times minus k, positive 8k, right? So this is my delta. After calculating the delta, I can go and solve the question. They are saying for which values of k will the equation have no real roots. For no real roots, it's when delta is less than 0. Where there is delta, I'm going to substitute 1 plus 8k and solve for my k. Can you see? So when we solve for k, minus 1, we're going to go that side, divide by 8. This one cancel this one, then k will be less than minus 1 over 8. So this means that for any value of k that is less than minus 1 over 8, when we substitute there and we try to get the roots, the x-intercepts, you're going to get that they're going to be no solution. In other words, they are non-real or they are undefined. So that's basically what it means. Okay, let's focus on a different, quite similar problem taken from Department of Basic Education past papers. Okay, so they're saying if f of x is equal to 0 has roots x equals to minus 5 plus or minus root of 3 minus 12k squared, all divided by 4, for which values of k will the roots be equal? So this one is quite simple because they've solved for x here, and you can see this is a quadratic formula, so we can just simply go and tell them our delta there. So our delta is anything inside the square root, so it is 3 minus 12k squared. But I need the values of k for which the roots will be equal. So for equal roots, we know that delta is equals to what? 0. Where there is delta, I can just go and substitute by 3 minus 12k squared, and then solve for what? And then solve for k. Can you see? It's really simple in that sense. So I can take my minus 12k to the other side, then it will be 12k squared. Can you see? Divide both sides by what? By 12. Divide both sides by 12. This one cancel this one. Then k squared is going to be equals to 3 divided by 12, which is going to be 1 over 4. Then to solve for k, I'm going to apply the square root to both sides, right? And don't forget plus or minus. Then our k will be equals to root of plus or minus 1 over 4. When you simplify this, it must be plus or minus 1 over 2. Can you see? So basically someone can just say it's when k is equals to 1 over 2 or k is equals to minus 1 over 2. So when k is equals to 1 over 2 or k is equals to minus 1 over 2, whenever you substitute that value there, you'll get that your roots are going to be equal. In other words, they are going to be the same. So that's it. Okay, so let's quickly move to this one this side. Okay, here they're saying for what values of p will 3x squared plus x plus 1 plus p is equals to 0 have equal roots, right? Have equal roots. Now it's a different problem, and I'll just keep on giving you more and more past paper questions that are like this, just for you to get an understanding of how standard this question may be, because their structure does not change. It's either they give you something like this one, or it's either they give you as in like in linear, whereas they didn't solve for that x, as in this case. So they said that for which values of p will 3x squared plus x plus 1 plus p is equals to 0 have equal roots, right? So in this case now you must first check if your equation is in the standard form x squared plus bx plus c being equated to 0, and we can see it's perfect, it's in that standard form. Then we can just go and calculate our delta. We know that delta is equals to b squared minus 4ac, right? So our a is anything that is multiplying with x squared, that is 3. Our b is anything multiplying with x, it is 1. Our c is anything that does not have x, in other words it's a constant, and you can see here is 1 plus p. So don't make that mistake to say it's 1, or some people can just say it's p only. It's 1 plus p because they don't have x, they don't have x squared. Anything that does not have x and s, so it's 1 plus p, that is your c, it's a constant. So I'm going to substitute. B is 1 squared minus 4, a is 3, and c is 1 plus p. Okay, so delta will be equals to 1 squared is 1 minus 4 times 3 minus 12 into 1 plus p. Then we can just simplify. Delta is 1 minus 12 times 1 is minus 12, minus 12 times p is minus 12p. Okay, so delta will be 1 minus 12 minus 11 minus 12p. So this is the answer for the delta, right? But we haven't answered the question. It says for which values of p will this equation have equal roots. So for equal roots, you must know the condition. It's when delta is equals to 0. Where there is delta, I can substitute minus 11 minus 12p is equals to 0. And then solve for what? And then solve for p. Then by taking minus 12 to the other side, to 12p divided by 12 divided by 12. Then p is going to be equals to minus 11 over 12. It means that when p is equals to minus 11 over 12, then our roots are going to be what? The roots are going to be equal. Okay. Okay, let's now focus on another problem. We are just treating as many as possible questions related to nature of the roots, and definitely after this session you'll actually see that nature of the roots, it's not hard, it's very, very simple, and their questions are always quite standard and the same. Okay, so it says, and on this example that I'm just putting here, you can just pause the video, try it on yourself, and then also just come back and see if you got the answer correctly. Okay, so they're saying the roots of the equation f of x equals to 0, x equals to minus 4 plus or minus root of 16 minus 4m into minus m plus 5, all divided by 2m. Determine the values of m for which the roots will be non-real. Can you see the questions are sort of like we are repeating the same thing again and again? Can you see? So in this case, it's quite simple because delta, you can just get it straight, right? So what is your delta? Delta is equals to what? 16 minus 4m into minus m plus 5, because it's that thing inside the square root. So they want you to determine the values of m for which the roots are non-real. So we know that our delta must be less than what? 0. So where there is delta, I'm going to put 16 minus 4m into minus m plus 5 less than 0. So now with nature of the roots question, you'll find that they are related to how you have to solve inequality equations, whereas there's this symbol here for inequality. So you must know nature of the roots and also how to solve inequality equations, right? So that's where the trick will be. Maybe if you don't know how to solve inequality equation, you cannot know how to determine these values of m. So we're just gonna solve it with our knowledge of inequality, right? So what I can do, I can first remove by minus 4m to say minus 4m times minus m. So it will be 16 minus 4m times minus m. It's going to be positive 4m. Then minus 4m times positive 5. It's going to be minus 4m squared, right? Here it's going to be positive 4m squared, because it's minus 4m times minus m. Then minus 4m times 5. It's going to be minus 20m, being less than 0. I can just write that properly. m squared minus 20m plus 16 less than 0. So I can go and calculate my critical values, or any method that you use in order to solve inequality equation. It's fine, but as for me, I'll go and calculate my critical values to say m is equals to, I can use a quadratic formula because this is a quadratic graph, minus b. My minus b is minus 20 plus or minus root of b squared, it's minus 20 squared, minus 4. My a is anything multiplying with m squared, and my c is that one without m, divided by 2 into a, right? So I just want to calculate my critical values there. Then yeah, okay, and we use the formula, m I'm getting 4, or m is equal to 1. So these are my critical values, m is equals to 4 or m is equals to 1. So this is not really, you can see that here I'm just trying to solve this inequality. Can you see? So with the nature of the roots, we have already applied the rule, and now it's just solving. It's algebra to say how can we solve inequality. So I'm just going to draw my number line from 1 up until to 4. So we can see, as I've shown you previously, you just check with this method, you just check your value of a is positive, and we know two shapes. There is smile when a is positive, and there is what? Sad when a is negative. So your a is positive, it's gonna be what? Smile. Then you just take that line there as 0 because y is equals to 0 there. So you check your inequality, it says less than, so less than is under, right? It's under the line because it's less than, it's 0, then less than is there. So you can see it's when m is between what? Is between 4 and 1. So when m is between 4 and 1, then our roots are going to be what? Are going to be non-real. So that's it. Okay, let's quickly look at this other one. They said the solution for a quadratic equation x equals to 3 plus or minus root of 4 minus 8p all divided by 4, where p is an element of, I think that's an integer. Okay, so determine the values of p so that the equation has non-real roots. So it's basically quite the same question, right? It's just that here they're using p. So same also, we need to determine our what? Our delta. What is your delta? It's something inside the square root there. It's 4 minus 8p. Can you see? So they are saying determine the values of p for which the equation has non-real roots. So for non-real, you must know the condition delta is less than 0. This condition, they won't tell you. You have to know them. Non-real, delta less than 0. Real, delta greater than 0. Equal, delta equals to 0. In that way. So where there is delta, substitute 4 minus 8p, then we say less than 0. So what's just left here is to solve this inequality. Then you would have determined the values of p. Can you see? So I'm going to take my 4 to the other side, and it's going to be minus 4, divide both sides by negative 8. Don't forget, I think in grade 10 you learned that when you divide by negative, or when you multiply by negative, your inequality sign must what? Must change its direction. So if it was facing there, then it will face there because we are dividing by negative. Minus 4 over minus 8, 1 over 2. So that will be the answer. So when p is greater than 1 over 2, then our roots there are going to be non-real. Okay, let's now focus on another problems from past papers. And in the next coming problems, it's going to be quite different. You'll see that these questions don't remain like this, right? As in, like, I know I've shown you quite a number of examples so that you can internalize and just have this standard way of thinking, that so that you can actually get total in this question. right? So but then you'll see as I start to move, I think in the next coming example, 2 of them, you'll see that it can be asked in a different way, and that's basically the last way in our method in which they can ask you, and it's quite really challenging for most students, but you'll understand it as we start to do it. But for now, let me also just show you this last 2 here so that we can quickly move back. Okay, so they said the roots of a quadratic equation are x equals to 3 plus or minus root of minus k minus 4 all divided by 2, for which values of k are the roots real. Now you need to determine delta, right? So for nature of the roots, you have to determine delta, because with delta you can be able to tell if the roots are real, non-real, and all that, or solve problems related to nature of the roots, because delta is a key thing here. So our delta is anything inside the square root there. It's minus k minus 4. Then they need the values of k for which the roots are real. You must know for real, delta must be greater or equals to 0, right? Or someone can just say delta is greater than 0. It's not wrong. It's fine. So I would prefer delta greater or equals to 0. Then where there is delta, we're going to put minus k minus 4 greater or equals to 0. And then we can go and solve for those values of k that they need. Can you see? So to solve for k, going to take minus 4 to the other side. It's going to be positive 4. Divide both sides by negative 1. Negative and negative cancel. Then k, because I've divided by negative, don't forget to change the direction of the inequality. When we divide by negative or multiply by negative, inequality sign direction changes. So it's going to face there to say our k must be less or equals to minus 4. So those are the values of k that will make that those roots to be real. Okay, let's move here now. Given f of x equals to x squared minus 5x plus 2, for which values of c will f of x equals to c have no real roots? Can you see? So what you have to do now, they are saying for which values of c when f of x will f of x equals to c. So when there is f of x, I'm going to put what? C, then it's equals to x squared minus 5x plus 2. Can you see? Great. So now I can't determine delta if my quadratic equation is in this form. I first need to make it in this form, x squared plus bx plus c being equated to what? To 0. So I'm just going to take c to the other side. I'll be left with 0. X squared minus 5x plus 2c is going to be minus c. Then it's in that standard form, perfect to go. I can go and calculate what? Delta. So delta we know is equals to b squared minus 4 ac. So your a is anything multiplying with x squared is 1, b is anything multiplying with x is minus 5, and c is anything that does not have x. It's 2 minus c. So don't make that mistake to say it's 2 or minus c only. It's 2 minus c. It's our constant there. So I can go and substitute delta is equals to b squared minus 5 squared minus 4. Our a is 1. Our c is 2 minus c. Don't forget. So delta will be minus 5 squared is 25. Minus 4 times 1 is minus 4 into 2 minus c. Then delta is 25. Minus 4 times 2 is minus 8. Minus 4 times minus c is positive 4c. Then delta will be equals to 25 minus 8, 17 plus 4c. Can you see? Then we are going back. They're saying we have calculated delta now, right? So they're saying for which this equation will have no real roots. For no real roots, delta is less than what? 0. So where there is delta, put 17 plus 4c less than 0, and I can go and solve for my c. I take 17 to the other side is minus 17. Okay, let me do like this. So I have 4c less than minus 17. To solve c, divide both sides by 4. Because I'm dividing with positive, my inequality sign will remain the same in the same direction. because I divided by positive. It only changes when you divide by negative. So c is less than minus 17 over what? Over 4. So that's your answer there. Okay, let's quickly go and look at some of the interesting challenging simple questions. Okay, let's look at these problems, and here's where most of you learners find it challenging, because here they just want you to prove, to show, using your knowledge of nature of the roots. So, but hopefully after this session you'll be able to do this. So they're interesting questions really. Let's start with the one in red. It says, show that the roots of 3x squared plus k plus 2x is equals to 1 minus k are real and rational for all values of k. So what they want you here to do is to show that the roots of this equation are what? Are real and rational. What do you know when the roots are real? In other words, they want you to show that indeed delta is greater than what? Or equals to 0. So they want you to show that indeed delta is greater or equals to what? 0. So that is what they want you to show. So at the end, you should be able to deduce or to conclude that therefore delta is greater or equals to 0. If you fail to prove this, it means that you didn't show them that indeed the roots are real. So that's basically what the question wants, and this is the last part of our session really. So before going and calculate delta, obviously in this question you definitely have to calculate delta, and you just need to simplify it like that. At the end you show that it's greater or equals to 0. If you fail to do that, then you didn't show them that the roots are real, because the only way to show that the roots are real, we must know delta. We must show that our delta is greater or equals to 0. So that's what they want. So we know in this kind of equation, we first need to write it in the form of x squared plus bx plus c being equated to 0. So it means that I will say 3x squared plus k plus 2x. I'm going to take these ones to the other side to be minus 1 plus k is equals to what? 0. Can you see? Now it's in that standard form. It's fine. I can go and calculate what? My delta. Delta formula says b squared minus 4ac. So what is our b? Okay, what is a, b, and c? So here's also what most students find it challenging, but this explanation will really help you to answer this kind of problem. A is anything that is multiplying with x squared. It's a coefficient of x squared. It's 3. B is anything that is multiplying with x. It is what? It is k plus 2. Can you see? So because k plus 2 is multiplying with x. C is anything that is not multiplying with x or x squared. So it's that constant. It's the whole thing. It's minus 1 plus what? Plus k. That is our C. We can go in the formula and substitute. Our B is k plus 2 squared minus 4. What is A is 3. What is C is minus 1 plus what? Plus k. Now I can go and simplify my delta in order to show that at the end delta is greater or equals to 0. If I don't show it, then I didn't answer the question. So now what have to happen is just to simplify this and to show that it's greater or equals to 0. Then we would have shown that they are indeed real and rational. Okay, so what I'm going to do is I'm going to expand this to be what? K plus 2 into k plus 2. Minus 4 times 3 is minus 12 into minus 1 plus k, right? So delta will be equals to what? K times k, k squared, k times 2, 2k, then this one 2 times k, 2k, then 2 times 2 is what? It's 4. Minus 12 times minus 1, positive 12, minus 12 times k, minus 12k, right? So delta will be equals to k squared plus 4k, because it's 2k plus 2k, plus 4 plus 12, I can just add the 2, it's 16, minus what? Minus 12k. Or I can also, okay, it's 4k here, 4k, I can say minus 12k, then 4 plus 12 is plus 16. So if I can just simplify that one, k squared, 4 minus 12k is minus 8k, plus what? Plus 16. Can you see? Now you have your delta is equals to this one now. Now you need to show that k squared minus 8k plus 16 is really, it will always be greater or equals to 0. How do you show it? You just simply manipulate it and factorize it like that. Okay, so I'm just gonna factorize it quickly. It's gonna be 4 times 4 minus 4 minus 4. So it's k minus 4 minus 4. If you don't know how to factorize, you can just use a quadratic formula to get those values of k. Then you can just put them in brackets and change their sign. So like that. Okay, so you can see now it's going there. It's k minus 4, k minus 4. K minus 4 times k minus 4 is k minus 4 squared. Can you see? Okay, so we know that k minus 4 squared will never be less than 0, will always be greater or equals to what? 0. Can you see? Because anything squared will always be above 0. If you square negative, it will always change to be positive. So anything squared will always be greater or equals to 0. So even our k minus 4 squared, we can conclude that therefore our k minus 4 squared will always be greater or equals to 0. And this is our delta. It means that therefore our delta will always be greater or equals to what? 0. Great. That is how you have shown them that indeed the roots will be real and what? Rational. So you have to know what you have to show. You have to show at the end delta is greater or equals to 0. So this is quite a challenging question, but very, very interesting. If you just find more questions related to this, and I'll just put 2 more on this session so that you can understand them deeply. Okay, let's look at the one in black and let's see how it goes. Okay, this side they said show that the roots of x plus h into x plus k is equals to 4d squared are real. You see, I just put the same question from a past paper so that you can understand how this thing goes and what you have to show are real for all values of h, k, and d. Can you see? So what do you have to do now? You have to show that the roots are real. In other words, you have to show that delta is indeed greater or equals to what? 0. If you fail to show this at the end, you have not shown or you have not answered the question. So in order to do that, we must first make sure, because we are given our equation like this, it's not like they've solved for x where you can just go and take delta on your quadratic. But in this way, we first really need to make sure that it's in the standard form x squared plus bx plus c being equated to 0 so that we can go and calculate our delta. Okay, so I'm just gonna do that. It's x plus h, x plus k is equals to 4d squared. Okay, just gonna remove expand this, x times x, x squared, x times h, xk, h times x, it's gonna be hx, h times k is hk. I can take my 4d squared to the other side, minus 4d squared is equals to 0. So this is x squared plus xk plus hx. Okay, take a look at something. Here I have a common factor of x. Can you see? I can take out my x, then I'll be left with k plus h. Can you see? Plus hk minus 4d squared is equals to 0. So I'm just trying to write it in this standard form. That's why I'm taking this common factor here. Or you can just simply leave it like that. Then you can go and calculate your what? Your delta. So delta is equals to b squared minus 4ac. What is your a? A is the coefficient of x. Any x squared, anything that is multiplying with x squared is what? Is 1. There, it's 1 there, right? What is your B? B is anything that is multiplying with x. It's what? Is k plus h. What if we just leave it like that? Anything that is multiplying with x, can you see? X is here. Is what? Is k plus what? Plus h. You'd still get the same answer, k plus h. C is anything that does not have x there. Is what? Is hk minus 4d squared. So after doing that, we can go and calculate our delta. What is our B? Our B is k plus h squared minus 4. What is our A? Is 1. What is our C? Is hk minus 4d squared, right? I can go and expand. When I expand here, I'll just do it very fast. K plus h squared is going to be k squared plus 2kh plus h squared. So you can open two brackets just to be safe, and you multiply each of them. But if you know how to do that fast, you can do that. Minus 4 times 1 is minus 4. Then minus 4 times hk is going to be minus 4hk. Minus 4 times minus 4d squared is positive 16d squared, right? So my delta is going to be equals to k squared. Can you see there's a common factor? I mean, like terms there. 2kh and minus 4hk is going to be minus 2kh plus what? H squared plus 16d squared. Can you see? Now you have to show that the delta is greater or equals to 0. So the rest of the things to show this is just simplifying and factorizing. Same as what we did this side, right? So what you can do now, you can see that this one here, can you see this one? Or maybe let me just use some red to show you this. You can see that that one you can what? You can factorize it, right? It can be factorized. How can you factorize it? By opening your two brackets, and it's gonna be, I think it's gonna be k minus h, right? Then we have plus 16d squared. Okay, so our delta, look at this, k minus h times k minus h is k minus h what? Squared plus what? 16d squared. Let's go and finalize now. We know that our k minus h squared is going to be always greater or equals to 0 because it is squared. Anything squared it's greater or equals to 0. And part of it there, it's 16d squared. And 16d squared also is going to be greater or equals to 0 because we have d squared there. It's going to be greater than 0 always. Therefore, oh, my space is limited now. But therefore, you can see that, therefore, it means that k minus h squared plus 16d squared is always also going to be greater or equals to what? 0, because this one is always to be greater than 0. This one is always going to be greater than 0. Therefore, we can conclude, can you see now? We can conclude that, therefore, this is our delta. Therefore, delta is greater or equals to what? 0. Can you see? Now you have shown that the roots are what? Are real. In other words, you have shown that your delta is going to be always greater or equals to 0. So these are just some tricky yet interesting and simple nature of the roots question. Let me just show you the last one and we can conclude this session for today. Okay, last one for the session. Show that the roots of c squared x squared plus cdx plus d squared is equals to 0 are non-real. Now they want you to show that the roots of this equation are what? Are non-real. In other words, what do they want you to show? They want you to show at the end that delta is going to be less than what? 0. If you fail to show this, it means you haven't shown that the roots are non-real, because the condition for non-real says delta must be less than 0. If you fail to show this, you didn't show anything, right? You didn't answer the question. So they are saying for non-real, for all real values of c and d, where c and d are non-zeros. Okay, so the first step is to ensure that your equation is in the standard form x squared plus bx plus c is equated to 0. And you can see they've already given you in that standard form. We can just quickly go and calculate what? our delta, because we really need to show that this delta is going to be less than 0. So we must calculate delta. So delta is b squared minus 4ac. So value of a is anything that is multiplied with x squared, right? Anything multiplying with x squared, and we call that coefficient of x squared. It's what? Is c squared. Can you see? B is anything multiplying with x. We call that coefficient of x. Is what? Is CD. Anything multiplying with x, there is CD. Then our C is the constant. It does not have any x or x squared. It's not multiplying with anything. It's a constant. Is what? Is D squared. Can you see? So we just go and substitute our B squared. It's going to be CD squared minus 4. What is our A? Our A is C squared. What is our C? Our C is D squared. Can you see? Then delta is going to be equals to CD squared. So it will be C squared D squared. Can you see? Because we are squaring the two there that are multiplying each other. So it's going to be C squared D squared minus 4. If I multiply the two, it's going to be C squared what? D squared. Can you now see that these two are like terms? They are like terms. C squared D squared minus 4C squared D squared. So our delta will be equals to what? 1 minus 4 is going to be what? Minus 3C squared D squared. Can you see? We have calculated our delta now. Here is it. But we need to show that this delta is going to be always less than 0. And you can see that indeed this delta is going to be always less than 0 for any value of D, for any real value of D and C that we can substitute there. That is non-zero because the condition says non-zero, so it's perfect. So you can see, we can conclude that minus 3C squared D squared is less than 0. It's always going to be less than 0 because these two are squared. They are going to be always positive, and positive multiplied by negative, negative multiplied by positive will always be what? Will always be negative. Can you see? Because minus 3 is negative. These ones are going to be always positive because they are squared. So it's negative being multiplied with positive is going to result in what? In always negative. Hence I'm saying minus 3C squared D squared is always going to be less than 0, right? Therefore we can conclude that because this is delta, our delta is less than what? Is less than 0. That is what we can conclude, and that's how you prove that. Okay. All right, great folks. We have reached to the end of our session, and this was nature of the roots, solving nature of the roots, and here I was just basically helping you to master this this topic of nature of the roots, so that any problem that you can get, you can just attack it like that, right? So I'll be doing more videos on mastering topic like that. I'll be following up with the one for number patterns, mastering number patterns and all that, mastering Euclidean geometry, all that. Will try to make those sessions. So ensure that you are subscribed and you have turned on the notification bell so that you can be notified every time I upload a video. Okay, so otherwise, if you like this video, can like it and just drop a comment so that we can hear your thoughts and how we can improve our sessions going forward. Otherwise, that's all for me, and thank you very much for watching, and goodbye.